Section 5.9a, I want you to be able to add, subtract, and multiply complex numbers. So in Section 5.5, you were introduced to complex numbers, and just as a reminder, a complex number is a number that can be written in the form a plus bi, where a and b are real numbers, and I equals the square root of -1. Today you're going to be adding and subtracting and also multiplying complex numbers. So let's just start out with adding. When you add complex numbers, you add their real parts together, the parts that do not have the I or without the I. You add those together, and then you add their imaginary parts, which are the parts with the I. So here's an example. If we just look at this, we have 4 and 7 are the parts that do not have the I. So we add 4 plus 7, and that's 11. And then we add the parts that do have the i's, so 3i plus a -6i is going to give us a -3i. Now just be careful when we get to multiplication. There's an addition here, and sometimes students confuse multiplying because there are parentheses around each of these complex numbers. That does not automatically mean to multiply. There's an addition sign in between, so you need to add the pieces of the real numbers together and then the pieces that have the i's together. All right, now let's move on to subtracting. When you subtract two complex numbers, another way you can think about it is to take the opposite of the terms that follow and add. Sometimes that helps students not make so many mistakes, and you don't need to do it like this, just as long as you remember subtracting. But this is what I'm talking about. I have 4 plus 3i that I have written over here, and then instead of doing -7, I just took the opposite of 7. So we're going to add a -7, and then we're going to add a positive 6i. So now I'm back to adding, so I take these two pieces without the I, and that's going to give me a -3, and then I go back and I get the pieces that have the I, so plus 9i. Okay, now we're going to multiply, and when you're multiplying complex numbers, you multiply by distributing or foiling just like you would in the real number system. The second step is you combine like terms, then you change all of the I squared terms to -1, and you write your final answer in the form of a plus bi. So remember, this part of the complex number has to be written last, the I. Okay, so here's an example with just a 3i multiplied by 4 minus 6i, and you're going to distribute just like you did in the real number system, and that's going to give you 12i minus 18i squared. Okay, so we don't have any terms to combine, but we do need to change the I squared to -1. So this becomes a -1, and just be careful here. This is a minus, so that's going to turn into plus 18. So we have 12i plus 18, and remember, final form that you want to write the I last. So 18 plus 12i. Now we're going to FOIL. So first outer, inner, last. So our first term is going to be 12 and then minus 3i, and then we'll go inside here to get plus 24i, and then minus 6i squared. Now we have the I squared here that needs to be changed to a -1, and we also need to combine like terms, so we're going to combine these two middle terms here. So we'll do the 12, and then this can be combined plus 21i, and we change the I squared to -1, so when we multiply that out, we're going to get a plus 6. So now we have the real parts here, so 12 plus 6 is going to give you 18, and then you have 21i. Okay, the next thing that we need to do is evaluate powers of I. When you're simplifying powers of complex numbers, the power of I should never be higher than 1. And you might wonder how you do that. There's a nice table here that converts all the powers of I up to and including I to the 12th power. Now, if you notice, they're all in groups of 4. And you have 4 powers of I -1, negative I1, and then you go to the 5th power, and it's I -1, I1. And then you go to the 9th power, and it's I -1, negative I1. So you have 4 powers of I, and then the pattern repeats. So the powers of I have a repeating pattern that allow you to express any power of I as one of 4 values, I, -1, negative I1. And you'll need to memorize this pattern. And one way, and this is one way you can use to memorize, you don't have to. If you come up with your own way, that's great. You can remember the phrase I won with the negatives in the middle to help you remember the pattern. And what I mean by that is the powers of I go I won, and then the negatives go in the middle. So I won, put the negatives in the middle. So what that means is I to the first power is I squared, you should know by now, is -1. I cubed simplifies to negative I, and I to the 4th simplifies to 1, because every 4th power of I is 1. Okay, now you are going to have to simplify powers of I. So let's see what we have here. The first one we have is 6I to the 14th. And what I did here is I just wrote out, or it's negative 6I to the 14th. I wrote out 14 I's, and I circled them 4 at a time because every 4 powers of I changes to 1. So this is a 1, this is a 1, and this is a 1. And what I have left is I squared. So basically, every 4 groups of I turns into 1. So we don't even have to worry about that because 1 times 1 times 1 times 1 is still going to be 1. So the way that you reduce this is you take the exponent and, oh, I must have showed you on the next one here. So basically what we have left here is I squared, and I squared changes to -1. So the way that we're going to write that, I squared is -1, but we had that -6 in front, so it's going to be -6 times -1. So this simplified would be just +6. Okay, now if I had 63, I sure wouldn't want, or I to the 63rd power, I sure wouldn't want to write out 63 I's. So you can think of how many groups of 4 I's do I have in 63? Well, another way to say that is I find out what 63 divided by 4 is. And what I do there is I just say, okay, well, 4 is going to go into 6 one time. So that's going to give me 4. And then I'll subtract, and that's going to give me 2. And I bring down the 3, so 23. How many times does 4 go into 23? That's going to go in 5 times. And 5 times 4 is 20. So dividing or subtracting there, I'm going to end up with 3. So I have 15 groups of 4 I's, and we really don't care about that because that is just going to turn into 1. So what I'm interested in is the remainder. I don't care about the 15. I only want the remainder. So I now rewrite the I to the 63rd power as I cubed. Well, we can't have any power of I that's higher than 1, and this is higher than 1. So now we go back to I won with the negatives in the middle, and we can change I cubed to negative I. So this whole thing is just going to change to negative I. Okay, now you have a few problems to try.